In CP3-3, we will be able to define a centroid, and CP3-4, you'll be able to locate the centroid, which is the center of gravity of a triangle. Let's go ahead and do a median exploration. So on a scratch piece of paper at home, draw a large triangle. Okay, so you're going to draw a large triangle, maybe something like this. And then what you're going to do is you're going to draw in the medians. So if you have a ruler, that's best to make sure you're finding exactly where each of the medians are. Once you find that midpoint, you'll bring it to the vertex, and then you're going to do that for the other two sides. And then what you should find is that they are concurrent. So where these medians meet is called the centroid. Now, if you cut out this triangle out of your paper, you should be able to balance it on your fingertip at that centroid point. And what you may notice is that if this is 1, then this other side over here would be 2. The centroid is formed from medians, and it is the center of gravity of the triangle, which means it's the balancing point of the triangle. The centroid of a triangle divides each median into 2 parts so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the opposite side. So what this is saying is if we have our centroid here, if this distance here is x, then what would happen is the second distance, so over here, that would be 2x. So if this distance here, if we called it y, then this distance here, we would call it 2y. So now we can add one more thing to our list, which was our centroid. Recalling what we already learned, the circumcenter is made from perpendicular bisectors, and its special property is that it's equidistant to each of the vertices. Then we had the incenter, which was made from angle bisectors, and that was equidistant to all the sides. Our orthocenter was made from altitudes, and there was nothing really special about those. Now we have our centroid, which is made from medians and is the center of gravity of a triangle, and it splits our medians into 2 lengths, x and 2x. Let's take a look at an example. Find the coordinates of the centroid. So we're trying to find the centroid here of a triangle with those 3 given vertices. Now, we could actually find this by using the vertex and a midpoint. So let's say we used the vertex A, and then we found the midpoint between B and C, and then we created a line using those 2 points, and we wanted to find it. We could, and it would work to help us find the centroid. But what actually happens is every single time, the way that it works out to be is average of the x's, average of the y's, which is much easier than having to go through the work of what we were just talking about. So we will do x1 plus x2 plus x3 divided by 3. Then we do y1 plus y2 plus y3 divided by 3. So if I look at my points, let's see, -8 plus 8 plus 4. Yes, you could have chosen any of them to be x1, 2, and 3 because you're just adding numbers. And then our y's, y1 is 2, y2 is 2, and y3 is -6 divided by 3. We can do some adding. -8 plus 8 is 0, plus 4 is 4 thirds. 2 plus 2 is 4, plus -6 is -2 thirds. And this is our centroid. All right, let's take a look at another example. Find the coordinates of the centroid of a triangle with vertices D, E, and F. Remember, we are going to find the average of the x's. So 9 plus 3 plus 0 divided by 3. Then we're going to find the average of the y's. So 4 plus 7 plus 4 divided by 3. Our x is 9 plus 3 plus 0 divided by 3 is 4. 4 plus 7 plus 4 divided by 3 is 5. So our centroid is at 4, 5. All right, example number 3 tells us that G is the centroid. G is the centroid. It gives us some measurements of some of the lengths, and we need to find some missing links. So we're not looking for an ordered pair for the centroid here. Rather, we're going to take what we're given. So AG is 12. So this length here is 12. GE is 5. AE is 8. FC, so this whole length here is 21. And we need to find the missing length. So find GD. GD is here. And let's remember with a centroid, if one part of it is 12, that means the other part, the shorter part, is half of that. So G to D is going to be 6. And we got that by doing 12 divided by 2. BD, or BG rather, here, that is the longer side of BE. So I know I need to do 5 times 2 to get 10. FG. FG is this part here. And if I know that the whole thing is 21, we want just 1/3 of that. So we're going to do 21 times 1/3, or 21 divided by 3, which is 7. Then it says I want to find the other part, so G to C, which is the other 2/3 of it. So we'll do 21 times 2/3, which is 14. And then E to C. E, because it's a centroid, it's a median. E is a median, so it cuts AC in half, which means then that E to C is also 8.